Why does going faster and faster make your time slow down, instead of just making you zip through more events per second? In the energy filament theory, time dilation happens because every particle in your body has to relax its internal rhythm to stay stable while plowing through the energy sea at extreme speeds. High-energy experiments have been shouting this at us for decades. Unstable particles sitting still decay almost instantly. Push the same kind of particles to speeds close to light and their lifetimes stretch to many times the normal value. Atomic clocks on fast planes and satellites tick a tiny bit slower than identical clocks on the ground. And when you correct for this, GPS works. If you ignore it, GPS fails. The data are not in doubt. The real question is what, inside you, is actually slowing. At rest, your inner world is busy. Electrons loop around nuclei and hop between levels on tight schedules. Molecules vibrate and twist. Chemical reactions step through their stages. Your heart squeezes and relaxes. Neurons charge and discharge. All of these small cycles are your true timekeepers. 1 second for you is basically how many of these microscopic loops have managed to complete before you look up again. When you are not moving very fast, those loops can run with their preferred tight beat. A lot of internal events fit into each external second. Now, picture yourself in a ship that is being pushed to a significant fraction of light speed. In this picture, your body and the ship are not sliding through empty nothing. They are a bundle of loops embedded in the energy sea, trying to cut sideways through that medium at high speed. The sea has a maximum relay tempo, that is the same ceiling that defines light speed. To keep your structure from tearing in this new regime, the internal cycles cannot keep hammering away at the same rate as before. The loops that define your atoms and molecules quietly stretch their beats. Electron circulations take slightly longer per lap. Molecular vibrations lengthen. Reaction chains run through their steps more slowly. Heartbeats and neural rhythms that are built on top of this microscopic activity also slow in lockstep. You can think of it like a marching band that is told to start running. At rest, each drummer can play dense fills and complex patterns. The music clock is packed. Once the band has to sprint across the field, they still have the same muscles and maximum effort available. But now, part of that effort has to go into forward motion. To keep from stumbling, they simplify and space out the beats. The tempo of the drumline drops even though each player still feels like they are working flat out. In this view, time dilation is that adjustment happening at the level of energy sea loops rather than human legs. To someone watching from the stands, the moving band's music is clearly slower. To a drummer inside the band, everything feels normal. Their own hearts, hands and ears are all following the same stretched rhythm, so they do not notice any changes. The same is true for a fast traveler. Compared to a lab on Earth, fewer internal cycles fit into each shared slice of comparison time. From the lab's perspective, your decays, your clock ticks and your heartbeat are all in slow motion. From your perspective, nothing is wrong. Your body and your clock and your thoughts are coordinated as always. Only the outside world seems to race ahead. Standard relativity wraps this in equations and says that as speed increases, the time coordinates along your path shrinks by a precise factor. This picture does not fight that, it just unpacks the symbol T into a concrete movie. Time is the count of particle cycles. Push a system close to the relay limit of the energy sea and, to stay intact, it must stretch those cycles. Fewer of them fit into the same external comparison interval, so your time runs slow relative to others. Both stories make the same predictions. One speaks in coordinates and metrics, the others in beats and loops carved into a medium. You can hold them together as two languages for the same observed effect. Tap follow, share it on New Physics, Clear Universe.